Hey everybody, this is section 3.2, properties of parallel lines. This is very similar to the last section. We're going to talk a lot about the same types of angles that we talked about in the last section, except we're going to apply what they look like when we have parallel lines in the mix. Okay, so your corresponding angles postulate. If you have a transversal that intersects two parallel lines, so L and M are parallel down here, okay, then corresponding angles are going to be congruent. So let's say that L and M are parallel, so they're marked with the two little arrows there on L and M to mark that they're congruent, or parallel, sorry. Then we know that all of our corresponding angles are going to be congruent. So 1 and 5 are corresponding, so therefore they're congruent. 2 and 6 are corresponding, so they're congruent, and so on and so forth. Okay, so based on that last postulate there, we have we want to figure out which angle measures 55. So we know that this one is 55 right here. Okay, well, we also know that angle 1 is going to be 55, okay, because they're going to be vertical. Okay, and we also know that the angle corresponding with the 55-degree one is going to be 55 as well, because we know that these two lines right here are parallel. So therefore 7 is corresponding with the one that's 55. So this is going to be 55 as well because they're corresponding. Just abbreviate here, core. And then we also know 5 then would be congruent because 5 and 7 would be vertical. You could also say that 5 and 1, or 5 would be 55 because it's corresponding with angle 1, and we already knew that angle 1 was 55 because it was vertical with this one. Alright, your next theorem says that if you have alternate interior angles, okay, or if you have parallel lines, then your alternate interior angles are congruent. So if L and M are parallel, marked with these little arrows right here, then we could say that 4 and 6 are congruent because they're alternate interior, and 3 and 5 are also congruent because they're alternate interior. They're on opposite sides of the interior of the parallel lines and your transversal. They're on opposite sides of the transversal. Okay, your next theorem says same side interior angles. Okay, if you have parallel lines, same side interior angles add up to 180. So remember, none of these theorems applied in the last section because we didn't have parallel lines. These theorems are only working in this section because line L and M are parallel. So therefore, we could say, actually this should say that 4, angle 4 plus angle 5 equals 180. And not that 4 is equal to 5. Okay, and then we should also have that angle 3, the measure of angle 3 plus the measure of angle 6 equals 180. Not that 3 is equal to 6. Because 3 and 6 are same side interior, 4 and 5 are same side interior, so they add up to be 180. Alright. Okay, next one says that if we have two parallel lines, then our alternate and exterior angles are congruent. So parallel lines L and M, your transversal, alternate sides of the transversal would be 1 and 7, and they're on the exterior of the parallel lines. So 1 is congruent to 7 and 2 is congruent to 8. So the only time that angles aren't congruent is when you have your same side interior angles theorem. And like I said, remember we crossed that off and we said that they were equal to 180 and not that they were congruent. Okay, so let's find, we want to figure out what the measures of angle 3 and 4 are here. So we want to also tell what theorem or postulate justifies it. So we have, all that we're given here is that 105 is right here. So we know from that angle 7 is going to be 105 as well because they're vertical. Okay, I'm not actually going to write out the justification on these, but it's something that you would do in your homework or on a test. Okay, so it's because these guys are vertical. All right, so from there, okay, I know that 7 and 3, right, are going to be corresponding angles. And I know that P and Q are parallel. So if P and Q are parallel and M is the transversal, 3 and 7 would be corresponding. So therefore 3 would also be 105 because of the corresponding angles postulate. Okay, then I also know that if I look at the 105 here, I know that 1 and 5 and 4 would be on the same side of transversal Q if line M, L, and M are your parallel lines. So L and M are parallel because they're marked right here. Your transversal is Q, so therefore 4 and 105 are same side interior, so you know they're going to add up to 180, so 4 has to be 75. Okay? Or you could have looked at it as 7 and 6 are corresponding, okay, because they're on the same spots with line L and M being your parallel lines and Q being your transversal. So 6 would have to be 105, and then 6 and 4 have to be 180 because they're a linear pair. Okay, and we could go through and find the measures of all these other angles too, but we just wanted to find 3 and 4. Alright, so here we want to find the value of y. Okay, here's our parallel lines right here. Alright, let's just name those L and M just so we can refer to them if we need to. Okay, so L and M are our parallel lines. Here's our transversal right here. So we know that 80 and these two angles combined together, the 40 and the y, are same side interior. Okay, well, same side interior are going to add up to 180. So that means that the 40 and y have to be 100 because there's already 80 used up here. So this one has to be 60. Okay, most of these you can do in your head, so there's not a whole lot of work you can show. It's always good to show your work, though, in case you do something wrong in your head. So show whatever you possibly can. All right, and that is it for your theorems on parallel lines. We will see you later.